Hello everyone, welcome back to my YouTube channel. Today will be diving into an analyzing and the visualization of the dataset. Today I have taken an example of Billionaires dataset. So let me give a brief introduction. So this dataset contains the statistics of the billionaires' personal details and what kind of industry are they running and the sectors or the demographics of the billionaires. So these are the attributes which are in the data sets with rank, final worth, category, person name, age, country, city, and source by which the billionaire earn. And next are the industries, country, citizenship, organization, self-made, or the inherited. Self-made is nothing but which they work from the scratch or they build their own company from the scratch. Inherited is they take from back from their family or to some dynasties. So next it's gender, birth date, billionaire's last name and first name, state, residence, and birth year, birth month, birthday, and CPI. CPI is nothing but consumer price index for the billionaire, and for the CPI change country and country's GDP. And these are the use cases which I use. Wealth distribution analysis, where we'll be exploring the distribution of billionaires' wealth across the different industries, countries, and the regions. And next is the demographic analysis. They investigate according to the age, gender, and birthplace. And next is self-made and inherited, as I explained before. Uh, and next, we'll be having economic indicators, study and the correlation between the billionaire wealth and economic indicators such as the GDP, CPI, and tax rates, and geospatial analysis. Here, we'll be using the geographical distribution of billionaires and their wealth on map trends over the time. So let me dive into the coding part. I'm using pandas as PD, import plotly express as px. Here, this is used for making the plots and charts. And next, import a plotly graph object. It's used for creating more customized and the complex data visualization. And import matplotlib, and this used for static and animatic interactive plots. And here import numpy as np is used for numerical computation. So here in second we are loading the data sets and displaying it. And here I'm finding the shape of the data set. And here I'm getting the information. Information is nothing but the data types of the data set which are loaded in the data set. And next I'm counting the total number of values which are present in the dataset. And next, I'm cleaning the dataset. So here, DF GDP of country refers to a specific column named as GDP of the country in pandas, and this column contains the string representing the GDP values for various countries. And dot string is used to treat the column as series of strings, allowing you to apply the string related operations to each element of the column. And next here, replace the dollar regex is equal to false is a method called on the GDP country column. It is used to replace a specific substring within each string in the column. And second argument is the replacement value, which is an empty string here. And in order the second string is the replacement value, which is empty string here, meaning you want to remove the dollar sign. Regex is equal to indicates that the dollar sign should be treated as a plain string and not as a regular expression pattern. This is important because dollar sign has a special meaning in regular expressions, and setting regex to false ensures it's treated as a literal character. So this first argument is the comma character, and it's what to replace the second argument is again the empty string. After running these two lines of the code of the GDP country column will contain GDP values without dollar sign or the commas, making it easier to convert these values to a numerical types for further analysis or visualization. And next, here DF is nothing but it is a data frame object uh, which allows you to store and manipulate the data in rows and columns. Here residence state region is is used to access the column name in the data frame. The unique is a method of pandas data frame that returns an array or list containing all the unique values present in the selected column. So let me run this code. So yeah, here it gives the unique values as north, south, west, and midwest. And here df is null. Then next it is used for to calculate the number of missing values or null values in each column of a data frame of the data frame. As you know, the df is the name of the data frame that we are working with is null, and dot sum is the summons that is applied to the data frame returned by df is null by default sums up the values along each column, treating true as 1 and false as 0. It is effectively counts the number of true missing values in each column separately. So here this calculates the total number of missing values in each column of the data frame df. I'm selecting only a required column whichever I need for the analyzing. Here I'm selecting rank, gender, final worth, categories, age, country. These are the column names I here. These are the necessary columns which I need to select. And next, whichever I have used, I'm converting into billions using a lambda. So here I'm visualizing for the distribution of billionaires based on their age and gender. This code provides to create an histogram or graphical representation of distribution of data from a data frame. So PX is a shorthand of for the Plotly Express module, which provides a high-level interface for creating various types of plots. PXR is a function that creates a histogram plot. TF of copy is a function that creates a histogram plot. Data frame containing the data you want to plot. Here I have these are the data whichever I have to plot contains, and here x is equal to age. Here color is gender. Color is equal to, and here I am giving the title. And next color is equal to specify, and here color is equal to gender. This specifies that the gender column will be used to distinguish between different genders of binaries. This means the histogram bar will be coded based on gender. Title is equal to distribution of binaries based on their age and gender. And figure to update. This line updates the x-axis of the plot to to have the title age. It adds a label to the x-axis to indicate what the values represent. And here figure 2 dot update. This line updates the y-axis of the plot to have the title count. It adds a label to the y-axis to indicate that it represents the count of binaries in each group. And this line displays the plot. It will open a window or render a plot like this in Jupyter Notebook uh, or web-based environment or whichever compiler whichever you are using. And this code creates a histogram that visualizes the age distribution of binaries with different colors for different genders. It labels the x-axis as age and y-axis as count. And next, I have used for plotting a number of billionaires by country, a top 10 billionaires in the country. This extract the top 10 countries with the most billionaires from the data frame. Here, it does it this by performing the here by using these steps. DF copy and calculates the count of the number of billionaires for each unique country in the country column. This results in Panda series where the country names are in the index, and the counts and a dot head selects the top 10 items from the series, meaning the top 10 countries with the most billionaires. And next, figure country, and this part of the line creates a bar using a Plotly Express, which we have seen before. Countries in the data source for the bar chart, and it contains the top 10 countries and their corresponding billionaire counts. And y is equal to country. Specify that country's name will be used for the y-axis, meaning that they will be displaying on the vertical axis. X is equal to countries values specifies that the billionaire counts that will be used for the x-axis, meaning that they will determine the width of the bars. And here I'm giving a title for this thing, top 10 billionaires, the number of billionaires by country. And here color disaggregate sequence is equal to this sequence px dot colors qualitative set 3, and this line sets the color scheme for the bars using the set 3 qualitative color palette. And figure country update title C. This line updates the x-axis of the plot to have the title country, adding a label to the horizontal axis to indicate that it represents. And next line figure update y. This line updates the y-axis of the y-axis of the graph. And finally, it plots the graph. This code is used by Plotly Express as we explained. Here, first let me explain you the output so then you can understand the code. It is basically it depends how much wealth is distributed according to their industry wise. So here in technology it's 15, fashion it's 14, manufacturing it's 8, and diversified it's 7%. So let me explain you the code. This slide creates a tree map or chart. It's used to this line is used for creating a tree map where paths of industries and values is final worth. And next time creating a title called as a wealth distribution and color disaggregate sequence. Color disaggregate sequence. Finally, sets the values that will determine the size of each tree map and rectangle of the here I'll be giving the size of the rectangle title. Color sequence is set one sets the color scheme for the tree map using the set one qualitative color palette. And here this update the traces of the individual elements or rectangles in the tree map to display both the label industry name and the percentage of the total in each rectangle. So when you hover over the tree map rectangle, you will be able to see the industry name. See, you will be able to see and tree map. You will be and the percentages represents the total wealth distribution. And next here, this line represents the layout of the tree map chart. Margin is the layout attribute that specifies the margins around the plot. It defines the space at the top, bottom, left, and right. T adds a margin of 50 units of the top, and L is equal to 0 sets the left margin to 0, right sets to 0, and B. This and this line displays the tree map chart. It will open a window or it will open and it displays. And this code will generate a tree map chart that visualizes the wealth distribution of it by industry. The size of each rectangle represents the wealth associated with a particular industry. And when we hover into a triangle, it displays the wealth of the industry and the industry's name. So this is the code. And next, here I'm using a top 10 countries with most 10 billionaires. Here I'm using a country count. DF is my data set name. I'll be selecting country and I'll be counting the values of here in the country column. I'll be displaying only a top 10. So here I'm calling here. So it displays the countries which having most number of billionaires. So United States, Germany, and India. These are the countries with the most number of billionaires. And next, here I'm using next piece of the next code. Here I'll be displaying the top 10 countries with the most billionaires. Where here I displayed in the table. Here I'll be visualizing it using a graph. So this line creates a new function, creates the new function, new figure for plot with the specified size 10, comma 6 and sets the width to 10 and height to the 6 inches. And next this line determines the color of the bar chart that will be displayed. The country count appears to be the total number of billionaires in the different countries. And here dot plot of kind is equal to bar is used to create a bar chart from the data in the country count. This line specifies that what we have to create a bar chart with bars representing the data, and color I'm setting it to the sky blue. And next here this line represents the number of billionaires which I'll be plotting in x-axis, and y-axis is the country, and title is top 10 countries, and it is the top 10 countries here. And this line displays that rotates the x-axis tick labels. It appears that the rotation parameter is set to 9 degrees, which rotates the x-axis label by 9 degrees. By 9 degrees, rotating label can be useful when we have a long labels or when we have to make them readable by displaying them in an angle. And then this is the code which displays the top 10 countries with the most billionaires. We can use many other using a pie chart or various things, but here I have used using a bar graph. And here I'll be checking the self-made and the inherited billionaires. Yeah, as I said you the before, the self-made is nothing but those who came without any background or without any knowledge. They have built their own industries from scratch is known as self-made. Inherited is something which they're taking over their fathers or the dynasty business whichever they have been doing in past. So here, this code tells the checking the proportion of self-made and inherited billionaires. Self-made represent here status. Here I am taking a DF is known as the data set from where I'll be taking self-made. First, I'll be let me tell you what is self-made and inherited. Self-made is nothing but which they have built there by their own from their scratch, without knowing the background or something. And inherited is something that taking over their father's business or taking over their dynasty businesses. So here, let me explain you the code. Here I first am defining self-made status, and from DF is the data set from where I'm taking, and I'm counting. Self-made is equal to PD dot data frame and frequency. Here frequency is the table column name, and self-made status and percentage where I'll be summing up the percentage. So true represents the self-made and false represent the inherited. There are self-made frequencies the 1812 and its percentage, and inherited is these are their percentage. So next explaining you using a visualization. So here I have used an pie chart. First I'm giving the labels as self-made or inherited. Colors of sky blue is light coral, and here explode variable is used a tuple that controls whether a slice of the pie the chart should be exploded or separated from the rest of the chart. In this case, the second slice which represents the inherited is exploded, moved outward by zero point 0.1 time, I mean zero point 0.1 unit, the radius of the pie chart. So this makes the inherited slice stand out from the rest. And here this set of line represents the figure size of the pie chart. It's whether the figure should be in square or both the width and height should be equal to 8 inches. 8 inches. And next here I'll be using a plot pie of self-made status. Seems to be self-made status is a variable that holds the data for the pie chart. It represents the distribution of individual with self-made and inherited status, and label specifies the quarter for this pie chart. And here autopic autopictorial 1.1 here this represents formats the display of the percentage in each slice of the pie chart to show one decimal place. And here start angle, and here the angle is 140, sets starting angle for the first slice of the pie chart. In this case it starts at 140 degree, which is self main. These are the which is a self main. And next this and PLT and here it gives the title of the distribution of self-made assets, and this is the thing. And so yeah, this is the code which I have used for visualizing in the self-made and the inherited status. And next I'll be telling you the top 10 top 10 states which are producing billionaires. I'll be telling the top states which are producing the billionaires state counts, whereas this is the data set name state I'm counting, and top states which are having a 10. Here the figure size is 14 in width and the height of the here. Here I'm SNS.bar plot is where I'm be plotting a bar graph, this line, and these are the title as top states producing billionaires and a font size of these thing. And plot.label is the state and state in x-axis, I'll be plotting a state and its font size, and y-axis, I'll be plotting number of billionaires in the font size, and here I'll be taking the font rotation or where rotation of the words or the font which I'll be printing, and same thing for y-axis font size and grid x-axis and plot grid is a function where axis is y and line style should be in a dotted and alpha is 0.7. So here I'll be adding a data labels for above the stars for I comma v in enumerate top states plot plot.text here I comma v plus by string v black color and center, and VA is for bottom and font size is 10. And next and finally I'll be plotting the graph. And this is the graph which I have visualization technique which I have used for top 10 states producing the billionaires. And next I'll be telling you the relationship between the GDP and the number of billionaires by country, as this is the most important analyzing which I have done. So here I'll be using this line here. So here GDP billionaires DP of group by. Here I'll be grouping it by GDP country and rank. And here reset index is a function used to reset the index of the resulting data frame. So GDP country becomes a regular column, and the resulting data frame contains the two columns GDP country and rank. So here I'll be defining the figures height and the width. So here a line tells that this creates a scatter plot using Seaborn SNS, which I have mentioned in top. Here, the each parameter does the specific the data source for the scatter plot, which is GDP of billionaires, and data frame sets the data for the x-axis, and y is for y-axis is rank, and and the size of the rank and size which I have used, and color. And next I'll be giving a plot title is a title which I have given, and next label in trillions. So here X label trillions, this is a label for x-axis indicating the GDP in trillions. The font is set to 12, and next y-axis I am using a number of billionaires and set to font size of 12, and rotation which I'll be using the angle or the rotation which I need to be used for the number of billionaires in y-axis and rotating angle, and tick and PL y-axis and font size for this and given as 10. And finally I'm giving a plot dot show Uh, here, which I'll be plotting Here I'll be plotting the relationship between the GDP and number of billionaires by country. So here, next piece of code which I have used is defining an average total tax rate in countries with the most billionaires. So here, first I'm defining top countries of the billionaires who pay the average rate of the total tax. Here I'm counting top 10 index. An average value is DF country is in top countries billionaires and total tax rate paid and mean. So average total tax which they are paying is 44.76. So
So now the next code is the billionaires distribution on the world map. In this code, I'll be showing you the number of billionaires in the world map through the world map. So here, the code starts with the longitude and the latitude coordinates for the scatter plot. The longitude country and the latitude country columns from the data frame are used to determine the locations of the data points on the map. And here we define the text of the person name and mode. Here, mode markers. This line specifies that the plot will use marker symbols to represent the data points on the map, and each billionaire's location will be represented by a marker. So next here it describes the defines the properties of the marker as size is 8 and opacity is 0.6% of the markers, making that somewhat transparent color. Uh, and here, the final word sets of the colors of each marker is based on the final word column from the data frame. The wealth of each binary is used to determine the color. The color scale is rainbow. It specifies the color scale to be used in the mapping wealth of the color. And color bar title is final word. That is the title. And next here figfy this line tells the command displays the scatter plot on the world map. It will open a window or render the figfy update goes projection type is natural earth. So here this line updates the geographic projection type for the map to natural earth. It specifies how the world map will be displayed. So here next here update layout title billionaires. This line offsets the title to the plot to the billionaires distribution. So this code creates a scatter plot on a world map to visualize the distribution of billionaires of each data point on the map represents a billionaire. So let me show you clearly. So it represents in the map like this. So this is the code, and next thing is uh, the number of billionaires are based on their rank and the gender. So first, it creates a histogram plot using Plotly Express. DF is the data frame containing the data that you want to plot. Here where x is equal to x is rank specifies that the rank column of the data frame will be used as data for the x-axis. Typically, it represents the position of the binary in a list of binaries sorted by their wealth, where color is equal to gender. That specifies that the gender column will be used to distinguish between the different genders of billionaires. And here, figure to update x-axis, it gives the titles to the x-axis, and figure to update y-axis, it gives the title to the y-axis, and finally, it displays the output of the code. That is this graph. So finally, in this code, it gives the trends of billionaire by CPI. This line groups the data frame dig CPI country column A calculates the mean average of the rank calculate the mean average rank of billionaires in each country. The reset index function is used to reset the index of the resulting data frame. So CPI country becomes a regular column, and resulting data frame contains the two columns: CPI country and rank. And here This represents the set of figure size. It describes the figure size for the plot. It specifies the 12 inches wide and 6 inches high. And this line states that the seaborne SNS dot line plot. Each parameter does the CPI billionaire specifies the data source for the line plot, which is CPI billionaires data frame, and CPI country sets the data for the x-axis, representing the cost of living index as CPI for different countries, and y is equal to sets the data for y-axis, representing the mean number of billionaires in each country, and color red sets the color to the line plot to red. And next, this line, the font is equal to 16. This states the title for the trend of billionaires by CPI, and it states the font size as 16. And next label CPI cost of living index as font size as 12, and plot Y label mean number of billionaires as font size as 12. And here this represents as the PLT. This lines are just the appearance of the tick labels on both the x and y axis, and plot x sets the rotation of the x axis labels to 90 degrees to make them more readable. Both a PLT ticks and the PLT tick sets the font size of the tick labels to 10 to plot the and to show. It shows the finally it displays the output, and which is this. So this is the video for today. I hope you got the idea of the data analyzing and the when visualization. So yeah, thank you.